Hari Om. In this session we continue with the potential, and here it is potential due to the charged spherical shell. Now let Q is the charge which is distributed on the spherical shell of radius r uniformly, and we want to find the potential at point X and also a point on the surface and also a point inside the spherical shell. Now we got the equation for potential, which is equal to negative of integral E into dr. Using this generalized formula, we can find the potential at X, which is potential outside, which is equal to negative of integral E outside into dr from infinity to r. Substituting for that one and solving it, we get V outside is equal to 1 by 4 pi epsilon 0 into Q divided by R, where R is the distance from the center of the sphere to the point outside. Now, like this, we continue and find the potential on the surface of the spherical shell. There we get V on the surface will be equal to negative of integral E outside into dr from infinity to capital R. This is the difference between the first one and the second one. And here you move the test charge from infinity to on the surface throughout the outside field. And solving it, we get the equation as 1 by 4 pi epsilon 0 into capital Q by capital R. Now, I give you the result of the third one, that is potential at a point inside the spherical shell. The equation is V inside will be equal to 1 by 4 pi epsilon 0 into Q by capital R, that is the same as which is on the surface, that is V inside is equal to V on the surface. Now you have to derive this particular formula and find out how these two are being equal. Okay. Now we move on to the next point, which is potential energy between two point charges separated by some distance. Now we consider here capital Q and a small q charge separated by a small distance r here. Whether distance is small or large, it's not a problem. Now we got potential is equal to work done per charge. Now here I consider V as the potential due to capital Q charge at this distance r. That is equal to work done divided by, that is work done in bringing this small q from infinity to this point divided by that particular charge. Therefore, work done to bring that charge small q from infinity to this point will be equal to potential into the charge small q. So, work done, W is the work done in bringing the charge small q from infinity to that point in the field of charge capital Q. This work done stores as electrostatic potential energy of the system of the two charges. So, potential energy U, which is equal to potential into charge, or U equal to 1 by 4 pi epsilon 0 into capital Q into small q divided by R. Now, here also we can consider the nature of the charges so that the potential energy between the charges can be either positive or negative depending upon the nature of the charges. So you have to identify when that potential energy is negative and when that potential energy is positive, and also identify the physics of this negative and positive potential energies. Okay. Thank you. Hari Om.